Are you tired of staring at your code, not understanding what the hell is going on? Are you tired of spending more time coding than actually making music? Well, guess what? We've got the solution for you! The Arduino MIDI Controller Code Generator! The revolutionary tool that will transform your coding nightmares into music-making dreams! Okay, so today I have something different for you. I always dreamed with a platform that I would just say how many buttons I am using or the pins I am using for the Arduino, and it would generate all the code for me. And in the past few months I have been working on exactly that. A platform that will generate the code for your Arduino MIDI controller. You just answer some questions and it will generate everything for you. So nice to meet you, my name is Gustavo Silveira, and here I teach people like you, nerds, to make MIDI controllers, among other things too. So today I want to introduce you to my new Arduino MIDI controller code generator. So let me show you in my screen. Okay, so let's take a look at our code generator. So I do have two options. I have the simple one and the advanced one, and I'm gonna start with the simple one. So what can you do here? So Arduino DIY MIDI controller configuration, I might change the name, I might change the layout, and I might change a lot of things. So don't worry if when you watch this video it's a little bit different. So what can we do here? So first, choose a board. You have the options Arduino Uno, Mega, Nano, Arduino Micro, Pro Micro, Leonardo, Teensy, and debug. So debug is for you to see the message that you're sending in the serial monitor. So before you make your Arduino a MIDI controller, I always advise you to choose debug, because you'll be able to see each message, and if you see each message correctly, it means that your circuit is right and your code's right, so you're ready to make it into a MIDI controller. So let's choose debug here. So are you using buttons? So let's check this. You can see that we have two options now, and if we check potentiometers, you can see that more options appeared for us. So now we just fill the blank spaces. So how many buttons are you using? So here is my circuit, so I am using 3 buttons on pins 2, 3, and 4, and 2 potentiometers on pins A0 and A1. So first thing, how many buttons are you using? We are using 3. Which pins are you using for the buttons? Comma separated. This means that we should put the pins as 2, 3, and 4 separated by comma, which are the pins I am connecting my buttons. Then how many potentiometers are you using? We are using 2 potentiometers. And which pins we are using for the potentiometers? We are using A0 and A1, separated by comma. Now we just press submit. We can see that all the code we need was generated automatically. So for example, here is the bug selected, we are activating buttons and potentiometers, here are the number of buttons, the pins, etc. And you don't even need to understand what's going on here now. Next, we have these options here. We have download libraries. Here you have the libraries, or you can install the libraries through the libraries manager in the Arduino IDE. Next option we have copy. So if we are in our Arduino IDE, we can just paste here. So now all the code is here, and we can also download the code. So I'm gonna press here, choose your folder, and save it. Now just open the file. It will ask you to put in a folder. You can press OK. And there you have it, the full code you need for your MIDI controller. What we need to do now is choose the board. I'm using Arduino Leonardo. If you're using another board, you come to Tools, Board, and find your board here. And then find your USB port. You are connecting your Arduino here. Now we can upload the code. And since we chose debug, if we open the serial monitor here, we should be able to see the message here if they are correct. So for example, 0 button on and off. So the first button always appears as 0. Any first component here appears as 0. So on, off, then on, off, on, off. So buttons are working fine. And then potentiometers. And here we should have a range from 0 to 127. Okay, so everything is working fine. Okay, so now we can come back here to our app, and for us to make it into a MIDI class compliant device, which is a plug and play MIDI controller, we need to choose here the Arduino Micro, Pro Micro, or Leonardo. The Arduino Uno, Mega, Nano will not be MIDI class compliant, so you need another software, which is Hairless MIDI, but I don't advise you to use Hairless MIDI, so I don't advise to use the Uno, Mega, and Nano, although you can. Hairless MIDI is outdated and is super buggy, so use a Pro Micro, Micro, or Leonardo, or a Teensy board. The Teensy boards can also be MIDI class compliant. So I'm going to choose here my Leonardo. I'm going to submit and copy since I already have my Arduino IDE here, and I'm going to paste. You can see here that now it changed the option where I choose the board, and inside my courses, I teach how to edit my code, just changing some numbers, but now it's even easier with that app. You don't even need to change the code here. You just change it there. So let's upload, and now I'm going to Ableton, I'm going to the options, and here in MIDI, I should now see Arduino Leonardo, which is right here. I'm going to choose track and remote in inputs. Since I'm not controlling LEDs or any output, with the Arduino, I'm not going to choose output, okay? But if I was using LEDs or motors, I would choose Arduino Leonardo in my out. Okay, so let's find a drum. Okay, so now if I press my buttons, and we can also use our potentiometers here and here. I have a delay here and a reverb. I want to add more things here, like a way to change the notes, but that's something I can do in my more advanced code. So what I want to show you now is the advanced version. So this version I showed to you right now, I'm going to leave it available for you for free here for you to download. So it's a great companion for the DIY MIDI controller workshop, where I teach you how to use buttons and potentiometers. But if you want to add encoders, multiplexers, LEDs, among other configurations, I'm going to show you the advanced app right now, which is here. You can see that we have more options already. We have the options for multiplexers, besides buttons, potentiometers, encoders, and it's a little bit more beautiful too. You can see here that it has some divisions. So what I want to do now is adding an encoder and show you how we can edit this app. So how do we use the advanced version here? You can see that we have more options. We have multiplexers, we have buttons, potentiometers, encoders, and we have other options that we can just activate or deactivate in the code. You can see that now is also more beautiful, more organized. So let me show you something. I'm going to activate my buttons, and you can see that we have 1, 2, 3, 4, 5 big slots. And if I add the multiplexer option, now besides the multiplexer configuration, we also have now 1, 2, 3, 4, 5, 6, 7 options, because now we can also configure where those buttons are in the multiplexers. And multiplexers are chips that can multiply the number of inputs of the Arduino. So for example, each multiplexer can multiply one analog input into 16. You can connect up to 16 components into one analog input using a multiplexer. So if you have 10 analog inputs, as you have in the Arduino Pro Micro, you can connect 10 times 16, so up to 160 components. Maybe you can't use that much in the Arduino Pro Micro because of memory limitations, but if you have a Teensy board, for example, you can. So since we are not using the multiplexers here, I'm going to deactivate. So first question, total number of buttons. Number of buttons in the Arduino plus number of buttons on multiplexer 1 plus number of buttons on multiplexer 2. So if you had multiplexers, you would sum all the buttons, including Arduino and multiplexers. Since we don't have multiplexers, I'm going to put the total number, which is only 3. Then number of buttons connected straight to the Arduino. So we have 3. And then pins of each button connected straight to the Arduino. So the buttons that are connected to the Arduino, and we are in pins 2, 3, and 4. If we had multiplexers, we would have the option number of buttons in each multiplexer and also to which pins in the multiplexers they are connected. Now we can also decide which kind of message we are sending with our buttons. Node ons and node offs, control change, we have also the toggle option, program change. Since I want to send only note numbers, note 36, 37, whatever, I'm going to choose note number, comma, note number, and comma, note number. If I wanted to send control change with the last button, I could put control change here. And capital letter matters, and the message value for the buttons or the message number. So I want to send message, let's say 36, 38, and 42. And here you can choose the MIDI channel for your buttons. Since I want MIDI channel 1, I'm going to put 0. If you are using the Arduino Pro Micro Leonardo, it's from 0 to 15, since you have 16 total. 0 to 15. If you are using the Uno, it's from 1 to 16. I won't put more instructions here later, but for now that's it. Okay, so let's configure our potentiometers, and it's basically the same thing. Total number of potentiometers including multiplexers, we have 2. Then the total connected to the Arduino, which is 2. Then the pins, A0 and A1. Sorry, A0 and A1. Which message we want to send? Control change or pitch bend? I want to send control change, so CC and then control change. So why would you send pitch bend? Pitch bend has a greater resolution, 14-bit instead of 7-bit, so you can have a better range, a better resolution, for example, to control filters, but also you also have the option of choosing high resolution potentiometers. So you don't need to send pitch bend, but you need an extra configuration in the DAW for you to use this option. And inside the course, I explain this in details. Okay, so control change, and here the control change or pitch bend number I want to send. So let's send, for example, 11 and 12. And the MIDI channel. Can be 0, can be 1. Let's put in another one. Let's choose 1. Now submit. Oh, okay, I found an error here in my app because it needs to be more than 0. Okay, so let's choose 1. I'm gonna fix this. So submit. You have the whole code now. However, this code requires more things. First thing, we need to come here to download libraries. I'm probably going to change to download files. So press here and you have a folder, a GitHub folder, where you can find a lot of things. You can download here and go to the folder. You have code and code generator. Here in code generator, you can actually find the source code for the app. So you can see how it was done. So it's totally open source. And you have this folder here where you can see a lot of files. You don't need to worry about that. What you need to do is download code. You need to go to that folder and you need to save it there. It's going to ask you if you want to replace one file, and yes, you need to replace. It needs to have that name. So let's replace it. And now you can just open. You can see that it has many options, and each option is to handle a different part of the code, such as encoders, encoder expander, a lot of things. But the nice thing is that you don't need to worry about anything. Just like the other code, it's all done for you right now. So one thing I didn't mention is that I chose debug as the board, and let's upload the code. Let's see if they are working. So you can see that everything is working perfectly here in the serial monitor. So this means that it will work when we make it into a MIDI controller, but I want to add the other option, which is encoders. So, okay, so how do we edit the encoders here in our app? So first, let's activate encoders. First, how many encoders we are using? 1. Which pins are you using for the encoders? Comma separated like this. So if we are using pins 5 and 6, we would put pins 5 and 6 between those curly braces or curly brackets for one encoder. If we are using another encoder, we put comma and then the other pins. Let's say 7 and 8. And if we had another encoder, comma, and then pins 9 and 10. So since every encoder takes 2 pins, they are going to go like this. Okay, so let me erase the rest. We're just using pins 5 and 6. Then the message values for the encoders. Which control change do you want to send? Let's say I want to send control change 5. But we have this other option here, which is Mach-E. So for example, if you want to make your MIDI controller compatible with the Mach-E protocol, you can select here the Mach-E protocol, and then you come to the code, you find the Mach-E tab, and here you have many options that you can send using the Mach-E protocol. If you want to make your encoder the volume 1 or VPOT or whatever, you just come here and copy. Since encoders are usually used as VPOTs, I'm going to choose VPOT 1, which means that if you choose a Mach-E control surface in your DAW, it will map automatically to the first VPOT or the first knob of the DAW. So I just copy and I would put VPOT. Since we don't want to use that, I want to be specific with the control change I want to send. I'm going to deactivate Mach-E and I'm going to choose, let's say, control change 5. Let's put the encoders in MIDI channel 2. And here we can also configure the encoder sensitivity. 4 is the more precise reading. It will give you 1, 2, 3, 4. But if you put a smaller number, it will be less precise, or the increments will be bigger, so the movement will be faster. So let's put 1. And it goes from 0 to 4, a number bigger than 0, like 0.1, up to 4. You can check here if you're using with Traktor, because it sends the message a little differently. And if you want to use high resolution encoders, so instead of between 0 and 127, you can send numbers between 0 and 16,383. I don't want that, so let's just submit. I'm gonna just copy the code, go to our IDE, and I'm just going to paste everything here in the first tab. Okay, so let's upload the code. Okay, so I got an error here. So you can see that I put a dot instead of a comma here. So let's go there and fix this. Here's the mistake. Okay, let's do it again. Let's come here, erase, paste, and try to upload again. I think I didn't press submit. Okay, submit, copy. Let's try again. Okay, now we had done compiling. So we should be good to go, done uploading. Let's check our serial monitor. What we had before, and now our encoder. So you can see that I'm turning counterclockwise and it's increasing the number, and clockwise it's decreasing. That's because I inverted the pins in the Arduino. I can invert the pins there, or I can just come here to the code. Instead of 5, 6, I can just put 6, 5. This will invert the encoder reading. So submit, copy, and let's replace this. Okay. So perfect. When I move clockwise, the number increases. When I move counterclockwise, the number decreases. Now, the last thing, as you can imagine, is making into a MIDI class compliant device. So let's change here to Arduino Micro, submit, copy, let's upload. Let's go to Ableton. So we should have the sounds we had before. We have the same drums, but now we have different sounds. So because I changed the notes there, now I'm playing different notes here in my drum rack. And now you have your fully working DIY MIDI controller. And here we made everything in the breadboard, which is very easy for us to prototype and test ideas. But once you make it here, or once you understand how the logic works, it's very easy for you to go to a final project. You take the idea of your prototype and then you make with wires, you build your enclosure, and you can use the same code or edit a new code in our platform. The simple code, I'll leave the link here for you to download, and the advanced code I'll put inside the Making Music with Arduino course, and there I have detailed instructions on how to use each component. For example, how to use multiplexers, the encoders, how to use MIDI DIN connectors, and there's many other things I want to edit here, and I will update this platform as I update the full code, since I am always updating when I have something new to add there. So as I mentioned in the video, the way I usually teach is that you come here and you just change some numbers. For example, here you can change the control change you are sending with your potentiometers, so that is quite easy already, but now with this editor it's even easier and faster. I always try to make what I wanted to have when I started. And if you want to have access to the advanced platform and to all my courses, please check here the Nerd Musician Pro link. There I have the Making Music with Arduino, which is where I teach you how to build MIDI controllers in the easiest way possible, just adapting my code to your needs. There I also teach you how to make enclosures, Bluetooth controllers, I teach you how to use motorized faders, which I'm going to add here in this platform, and many other things. Also in the Nerd Musician Pro, you can find the KiCad PCB design course, where I teach you how to make super professional printed circuit boards. This is great if you want to sell your MIDI controller, if you think you have an idea and you want to make some money out of it. And if you want to learn how to code, I have the Arduino programming course. There I teach you how to code from scratch. So tell me here in the comments which features you'd like me to add in the platform, in the free one and in the advanced one too. So see you in the next video.